Hey guys, we are starting a new series in which we'll be making innovative projects and we'll be sharing it with you. In today's project, we have made a DHT11 based a smart weather station which will display the result on an LCD screen. Also, it will push the data to a cloud server. To make this project, you will be requiring a Node MCU, also known as Esp8266. Along with this, you will be requiring a DHT11, which is a temperature and a moisture sensor. Along with this, we'll also require a half breadboard, an LCD with I2C attached, some jumper wires, and finally our battery module. So let's start with it. As you can see, this is the pin out of ESP8266. The same will be available in the description. Yeah. So let's take our breadboard and we will connect the Node MCU to it. As you can see, I have already connected my Node MCU to the breadboard. Okay. The first step will be to attach DHT11 to it. Yeah. So I have another pin diagram for it. As you can see here. So we'll be making the connection for this DHT11. For this, as you can see, we'll be requiring 3 jumper wires, a black colored, a brown color or a red color one. You can use any color wire, but I'll be following the same color code to match the pattern. Yeah. So let's go with it. Here I have 3 jumper wires, that is a male to female jumper wire. Yeah. And let's see how to connect this jumper wire first to DHT11. On this DHT11, if you carefully see, there are 3 pins, a plus, a out and a minus. Okay, so I connect the red wire to the plus, the brown wire to the out or the signal, and the black wire to the minus. Now note, different DHT have different pinouts. Maybe like they have the same pinouts, like the 3 pins will be same, but the position will be different. So you have to carefully look on to which pin is what. Okay. Now let's see. On this ESP8266, I have this 3v3 pin here, that is the top left one. If I show this diagram here, we have it here. That is the 3v3 pin here. Yeah, that is the 3v3 voltage, 3.3 voltage, and the ground pin here. Okay, so you'll be connecting the plus and minus to both of these pins. Yeah. So if you see on the top, on the bottom left, I'm connecting the the red wire to the 3v3 and the black wire to the ground. Now for the signal wire, I'll be using this GPIO0, that is for the D3 pin, GPIO0. Yeah. So that is the 4th pin. If you see, that is the 4th pin, first, second, third, fourth pin from the top. So it is first, second, third and 4th pin from the top, which I have connected here. Okay, so this is the connection for DHT11 and Node MCU, or also called as ESP8266. Now comes the LCD with I2C attached. I2C is a way of communication. Yeah, you also get normal LCDs with multiple connectors, but the number of wire requirements will be more there and the circuit would be complex, so we chose this one for that. Yeah. Again, coming back to the circuit diagram here, so we see that this circuit has 4 pins. Sorry, the image is tilted. VCC, ground, SGA and SCL. Yeah. So again, I'll be taking 4 jumper wires First, the red jumper wire. For this, we'll be requiring male to female again. Okay, so I've taken some male to female jumper wires. So red jumper wire will go to VCC. Okay, then comes the ground wire, which is black in color. Yeah, I have a black male to female jumper wire. Then we have SDA and SCL. Okay, on this also you can see we have SDA and SCL. For SDA we are using a purple jumper wire, and for SCL we are using a blue jumper wire. So don't get confused there. Just push it in and it's good to go. Yeah. Now we need to connect this onto the Esp8266. Yeah. So let's connect it. So this red wire will get connected to VIN. VIN, that is the bottom left one, VIN. If I use this image here, it is the bottom left one. Now why we are using VIN is because this display here uses 5 volts, while DHT11 works with 3.3 volts as well as 5 volts. Yeah, so that is why we'll be using VIN here, followed by which we'll be connecting ground to the ground. Yeah, then comes the SDA and SCL pins. If you carefully look onto this image here, it's connected to D1 and D2. Okay, so the blue wire, because we are following the color code, is connected to D1, and the purple wire is just connected to the bottom of it. So all the 3 signal pins are just nearby. So this was our connection for Esp8266 and DHT11. Now what we'll do is we'll go to the code section and we'll see what is required there. Yeah.
Now that we have made the circuit, let's move on to our coding part. To code it out, we first have to install our Esp8266 library to the Arduino. However, in this tutorial, I won't be teaching how to install the Arduino IDE. You can look on to the previous videos for that. Yeah. So, go to Files and go to Preferences. Now, copy this link inside the Preferences. The link will be available in the description. Press OK and close your Arduino IDE. Again, restart the Arduino IDE so that the link gets configured. Now, when you go to the tools and go to the board option, you will be able to see Esp8266 boards, and here I'll be selecting generic Esp8266 module. Now that our ESP is configured, let's plug our Esp8266 to the computer using a micro USB cord. Now you can see that I've got a COM3 available for my Esp8266. So we have configured our Esp8266 for our project. Now what we have to do is we have to install the libraries which we'll be using with this project. For that, go to Sketch and go to Include Library, and then Manage Libraries. Again, Sketch, Include Library, Manage Libraries, and click. The first library which we'll be installing is DHT11. So search for DHT11, yeah, and then you will get one by Adafruit. Okay, now this is the library which will work with our DHT11, and as obvious it is by name, and it will give us the necessary outcome. So here the version number has to be 1.2.3. Make sure it is that, because with different versions you might get some error, and this is the tested one out, and press on install. The second library which we need to install is Firebase Arduino based on Wi-Fi 101 by Mobit, as you can see this one. And the version is 1.2.3, the latest one. Install all. Don't forget to install all. Scroll down a little bit and you will find Firebase Esp8266 client as well. So we need to install this library as well. I'll install this library, but the version here has to be 3.7.5 and press on install. Now that is done, search for Arduino JSON. This library will help pass our data from the Arduino IDE to the cloud that we'll be doing. And here you have to search for Arduino JSON by Benoit Blanchon. Yeah, and the version here will be 5.13.5. Sorry, and press on install. The last library which we'll be installing from here is NTP client. This library will help you, with the time, the date and the time formatting. As you could see in the previous preview that in an LCD display we display the time and the day. And here you will be selecting by Firebase when work. The latest version is fine. Just go for install. Along with this, now we have to install our LCD library, LCD liquid crystal I2C library, which you can see here. Okay, so I'll go to Google. I'll search for LCD with I2C library. Okay, LCD, I'll search for LCD I2C library like this. And then I'll find this library which is by FTE Brander, and I'll just click on that, go to code and do download zip. I've already downloaded this library. Okay, now when you have downloaded this library, go to sketch, go to include library and do add not zip library. Navigate to the library zip file. Okay, don't extract it, just you can see it's .zip here, and just press on open. And if I'm not wrong, everything is done, the library portion. I'll verify it by clicking on the verify button. It might take some time. Yeah, till that what we can do is let's go to our Google and configure our Firebase. Okay, so on Google what you have to search is for firebase.google.com like this. Yeah, and here it will ask for sign up. I've already signed in, as you can see my profile picture is there. It won't ask me. Okay, go to console and you will see a lot of projects here which I've already designed and created. And here I'll go to add project. Give your project a name. For mine, I'll be installing DHT11 weather station. DHT11 weather station, and press on continue. Yeah. Then scroll down a little bit and press on continue again. For select an account, select the default account for Firebase and create project. This thing might take some time, so let's go back to our Arduino to see if everything has compiled. As you can see, it's done compiling. Okay, that means our libraries have been installed properly. So there are two more things that we have to do in the code. First, you have to mention the Wi-Fi SSID in this quotes here. For me, my Wi-Fi name is Realme. It's my mobile hotspot, and my password, I'll put my password. Okay, Yeah. So right now, don't upload the code. We still have to set up some Firebase and we need to link it with our code. Okay. Now press on continue. Once you do that, you will have an interface like this. Here, I want you to go to real-time database and create a database here. Let the location be US states. However, you can also select Singapore, because it's near to Asia, but let it be here. I'll be using the same for a project here. Press on next and start in test mode. Start in test mode. Okay. You can see just read it out and yeah, enable it. Yeah. So you can see this are the name of the project you can see here. Now what you have to do here is you have to copy this link, okay, this thing, but don't copy the entire thing. The everything after slash, the double slash up till .com. Okay, leave the last slash as well. It should not be included. Just copy it and paste it in your Firebase host like this. So you can see from DHT11 till .com, I've copied everything. I've not included the slash, the last slash. So this is the first thing that you have to do. The second thing, what you have to do is go to settings, go to project settings, go to service accounts, yeah, and go to database secret. Copy the secret code here, yeah. Just let me check it. Still recording, yeah. Once it is done, upload the code. Make sure your hotspot or your Wi-Fi is on and the password here is correct. So as you can see here, I've connected my DHT11 to pin number 0, that is GPIO 0. So that is why we have written 0. If you are not using the GPIO 0, if you're putting some other GPIO pin, you can refer the diagram, for the pinout diagram and put the correct pinout here, the pin number here. The rest code is what we have already done. You just have to upload it and it's good to go. So as you can see, it's still uploading for me. It might take some few seconds to upload. It's 87 here. It's done uploading. Yeah. Now within few seconds, I'll just go back to my real-time database here. And just within few seconds, it might take some time to configure, and I'll start getting my data. We got my data. When I click my DHT11, you can see I'm getting humidity and temperature. So when I click to humidity as well, you can see my humidity on Thursday at 8:53 is 51%. So you can just click on the data, I'll just open it here, and my temperature is 30 degrees Celsius. So this is what our configuration is. If you are not getting the data here, make sure your password is correct. We'll also see how we can verify it with our, if you're getting the data on the LCD screen but not here, maybe your configuration code here is wrong. Yeah, but if you're not getting the data on the LCD screen itself, then maybe your circuit is somewhere wrong. You need to recheck your circuit. So let's move on and let's modify our circuit a little bit more so that it will help us with the project.
Now that we have coded it out, let's see how it looks on an LCD screen. So here it's showing connecting, so it's waiting for my ESP to connect to my Wi-Fi. Connecting, it shows my IP address, and tada, it gives me the output, my humidity and my temperature. Okay, now I'll disconnect my wire here. If we want to use a battery pack like this one, a battery with a snap, so that our weather station becomes a little bit modular. What we need to do is we need to get a breadboard power supply like this one. I got this from the WitBlox store. Okay, now in this power supply, the breadboard power supply, I made a modification. Okay, that means my jumper here on both the sides, if you see, is between 5 volts and off. Okay, so the default comes between 3V3 and off, something like this. On the bottom side I put it between 5 volts and off on both the sides. Now make sure your 5 volts here aligns with the red line, on both the sides, and snap your plug. Yeah, so this is the modification, first modification that is required. Second thing, what we'll do is I'll remove this red wire and connect it to the red rail. That was the red rail which is connected to the 5 volts. I'll remove this black wire and I'll connect it to the black rail of the breadboard power supply. So my breadboard power supply is indirectly powering my LCD screen, but there is no power supply to my Esp8266 yet. So what I'll do is I'll get 2 more jumper wires, a black male to male and a red male to male. Connect the black male to male to the same row, that is the ground rail, and connect it to any of the ground pins. Similarly, connect the red wire to the red rail and put it to V in. That's it. Now I can use a battery pack like this. Okay, carefully snap it in and push the button. You can see a green light coming here, and again you can see the outcome on my LCD screen. Yeah, however, there's a better alternative to this. You can either get this 18650 battery pack, because this will last a lot longer than this one. Okay, this is a 16,000 milliamps battery pack, and you can easily connect it with a snap like this, to your power supply and make it work. So the duration with this will last a lot longer than the earlier battery pack. Or else you can use a 9 volts adapter like this one. Yeah, so this is 9 volts 2 amps adapter. You can use 9 volts 1 amp adapter, should work fine. Again, I got this one from the WitBlox store. Yeah, so this is our project. I hope you enjoyed it and you'll be building a lot more like this. That's it. Tada, bye bye, thank you.